Session was originally supposed to be presented by my coworker and good friend, Denny Cherry, who unfortunately is in the hospital right now and is unable to be at the conference. This is mostly Denny's content, so I want to give him most of the credit on this. This is one of my favorite talks to give to a group of DBAs and maybe folks who don't get as much exposure to the rest of their infrastructure as they might otherwise see in a really small organization. Because I know I was a DBA for almost 20 years, especially in a larger organization. You may not get a good understanding of what your storage environment is. Your storage teams tend to handle those sorts of things, and you don't always have a good understanding. So it really helps if you have a good understanding of the terminology and functionality of different storage appliances and how they work. So when you're talking to your SAN admin, you can make a justification for why you need the 2 terabytes of data that you need. We're also going to talk about in this session some lies your SAN admin tells you, because that's an important thing to know, because they do lie to you. We're going to talk a little bit about backup, and I just kind of want to give you a little bit of a history of this session. We're definitely seeing a little bit of a big evolution rather in storage. Probably, Denny and I both have given variants of this talk probably for the last 10 years. And storage has changed tremendously. Probably the biggest innovation is the widespread adoption of flash storage, which is orders of magnitude faster than spinning disk. So we're going to talk a little bit about flash, what you should do, what you shouldn't. Hopefully you have a good budget if you want that stuff. It's still kind of pricey. We're also going to talk a little bit about cloud. I have like a couple of slides on Azure storage. It is quite different in the way you configure it, so I wanted to talk to that. And we'll talk a little bit about the way SQL Server just does I/O in general, so we're all on the same page. Please silence your cell phones. If you get a call, I reserve the right to come answer your phone and invoice you for if it's an on-call charge. So I'm Joey D'Antoni. I'm Principal Consultant at Denny Cherry & Associates Consulting. You can find me at LinkedIn/Joseph D'Antoni, Twitter at jdanton. I'd like to probably, for the size of the room, hold questions until the end today. But we'll leave some time for questions. I'm a Microsoft Data Platform MVP and a VMware vExpert, and I've written a couple of books on SQL Server. So today's agenda, the first couple of things I want to talk about is terminology, and this is really important because we hear a lot of terms tossed around like LUN or fiber channel and those sorts of things that your SAN admin may say. But you don't always necessarily know what they mean. You want to have a good understanding of the right things to say and how everything works in your storage environment. We're going to talk a little bit about array caches. So when we talk about arrays, we just mean a storage appliance or a SAN. A SAN is really nothing more than a fancy computer and a whole bunch of hard drives or SSDs. The SAN admin will like to call that device an array. And that array, since it's a computer, is going to have memory. Obviously to buffer reads and writes. And we're going to talk about how that works and how that affects SQL Server. We're also going to talk about different RAID types. This is included because I want you to have a good understanding. For the most part, on most modern storage arrays, you have very little control over RAID types, and things are really different than the way they used to be, where you had a fixed number of disks that were presented to you as a LUN. And we're going to talk about that and how things are different. We're going to talk about the different types of disk and disk alignment, which for the most part is still a non-issue now. Is anybody starting Windows Server 2003? Wow, I got about 10% of the room. I'm sorry. Well, disk alignment matters to you folks. Everyone else, you don't really have to worry about it. We'll talk a little bit about all flash and how arrays are built, and then we'll talk about cloud storage. So just to kind of level set, and this is a grossly simplistic explanation of how this happens. So if anybody knows deep knowledge of internals, you'll know this is grossly simplistic. I just wanted a basic example. So databases use buffer pools because disks are slow. And this applies to pretty much every relational database engine I've ever seen, which is probably 20 of them. So if we have an application, and that application does an application call J, so this slide's a tribute to Denny, who makes a lot of misspellings. That's actually application call, and I built it, Denny didn't, so I'll take the blame, but I'll say it's honoring Denny. We have an application call. It's going to attempt to read data from the buffer pool. If the pages that it needs to read that data from aren't in the buffer pool, it's possibly gonna make a call, if it needs those pages, down to the MDF file, retrieve those pages into the buffer pool, and send that back to the application. Writes work a little bit differently. Writes are also gonna write to the buffer pool, and occasionally a checkpoint's gonna happen or something else is gonna happen to cause a checkpoint, and then that checkpoint's gonna get flushed down to the log. Fairly basic concept. The important thing here to know with databases is all our writes have to be transactionally consistent or we can lose data, and we'll talk about places you could potentially lose data and potential causes for corruption during this talk. SQL Server stores data in 8K pages. Unlike some other database engines, which gives you the option of storing data in different page sizes, we only do 8K. SQL Server mostly does I/O in 64 kilobyte chunks, which is 8 pages, or an extent as we call it, but not always. So there's a lot of times SQL Server will do much larger I/Os than that. So it really, that part kind of depends, but a lot of times when we do benchmark testing on storage devices, we'll do it with 64K I/Os. So some storage terminology. And most of these terms are gonna be SAN terms that we're gonna talk about here. But LUN is logical unit number. So frequently you'll ask your SAN admin for a LUN, and you think of that as just a volume or something, but what LUN stands for is logical unit number. The host. This can be a confusing term, because if you're working in a virtual environment, typically the host is gonna be the physical server that your virtual machine is gonna run on, and then your individual virtual machine is gonna be known as a guest to your virtualization admin. Frequently in many organizations, your virtualization admin and your SAN admin are the same people, so just be aware of that. But this is where we're presenting from a SAN perspective, a host is just a server or the servers that we're presenting the LUN to. SAN stands for storage area network, you probably know that. But the key thing here is it can network. So all of our devices, all of our hosts come in over either iSCSI or fiber channel to connect into that storage area network. The fabric, this term's a little bit more confusing, and I hate to use the word nebulous because it implies clouds a little bit, but this is the fiber network that makes up the SAN. A lot of the newer modern SANs that come from the newer startup companies have given up on fiber, and they use just a ton of Ethernet. And they also use commodity switches. In the past, there were companies like Brocade that made specialized switches just for fiber channel switching for SANs. Now that's going to more of a commodity infrastructure. In general, you'll see that. You see fewer and fewer specialized appliances. Oh, and by the way, that fiber isn't a spelling error. Fiber is spelled differently when you're referring to fiber optic communication versus fiber in a SAN. There's some international standards agency that decided on this, and apparently the people who built the SAN were British, so we went with fiber spelled that way instead of FIBR. And then finally the array. This is the big box with spindles in it that potentially costs millions of dollars. By the way, one of the best reasons to make really good friends with your SAN admin is so you can get taken out to dinner and golf by the SAN sales representative. Pro tip. So disk drives. Hard drives can only spin at 15,000 RPMs. There's a reason for this, and it's one of those things that we can't get around. It's called the laws of physics. A hard drive will start to destroy itself if it tries to go faster than 15,000 RPMs. From the time that computers, x86 computers were a thing, hard drive performance improved roughly 50 times. So we went from, I think, 3,600 RPM, or maybe even 1,200 RPM, I don't know what the oldest drives were, that's the oldest I remember, to having 15,000 RPM drives. Where we did gain is capacity. So you have 10 terabyte volumes now. One kind of important thing to note there, typically, and this isn't always the case, as a hard drive grows in size, its speed is reduced because those larger platters just don't spin as fast. I built this slide in about 2012, I think, and from 1984 to 2012, CPU speed had increased 5,521 times, while hard drive performance had only improved 50. So that's quite the order of magnitude of difference. One of the things we like to talk about when we talk about, oh man, PowerPoint crashed. It has not been a good week. I saw this happen to Mark Rusinovich at TechEd one time. And it was at the end of a session where he had lost his mic, his connection to Azure died, and something else bad happened. And right when he got to the last slide, PowerPoint crashed. So fun. So latency is one of the terms we like to talk about with disk. Disk latency typically for a spinning disk is around 13 milliseconds. That's pretty high on an older disk. You can see them a lot lower now. Solid states are going to be microseconds, if not nanoseconds. But it really depends on the quality and rotational speed of the hard drive. However, to reach, man, my AV luck this week, to reach RAM only takes 83 nanoseconds. How big is the difference? So if RAM was an F-18 Hornet with a max speed of roughly 1,200 miles an hour, which is 1.5 times the speed of sound, disk access would be a banana slug. And this is, of course, talking about spinning disks. Solid states are a lot faster, but so quite the difference in latency. So this is why we want to do as much as we can in memory. This is also why it tends to be cheaper, especially if you're talking about physical servers, to buy more memory as opposed to buying more IOPS. Because more IOPS, you need to buy more disk or more solid state devices, and that can be kind of expensive. Memory's pretty cheap. I was talking to someone today at Microsoft who recently worked on a server that had 56 terabytes of RAM. And the server was only a couple $100,000, which shocked me. I was amazed at how much RAM prices have come down recently. So just a couple of other storage terms. The disk is going to how your OS sees the LUN when it's presented. So even though your volume may be made of multiple disks, you're only going to see one disk. And depending on the type of storage array you need, you may need a multi-pathing driver to talk to all those disks. And occasionally, once in a blue moon, I haven't seen this in a while, but Windows will see a SAN disk as like 5 disks, even though it's actually just one LUN. And that's usually because the operating system doesn't have the right driver for your storage array. Spindle is another name you'll hear your SAN admin use. These are the physical disk and the storage array. IOPS is, once again, another term. This is a physical operation to disk. A lot of times your SAN admin will ask you, how many IOPS does your application need? And calculating IOPS from SQL Server used to be really hard. There are some perfmon counters you can use in the past, before SQL Server 2014 in the physical disk area, but trying to capture all the I/O that SQL Server was performing was quite challenging. Starting with SQL Server 2014, Microsoft introduced something kind of interesting. If anyone's ever worked with Resource Governor, and yes, it's an enterprise-only feature, but this is kind of cool, and I actually installed Standard Edition to test it. In 2014, Microsoft introduced disk governance into Resource Governor. You can limit the number of IOPS that an individual volume can perform. And what did that mean for us? They had to track it somewhere. So they introduced a perfmon counter that tracks disk read operations and disk write operations for a Resource Governor resource group. So the cool thing about that is you can turn on that counter and capture all the IOPS your SQL Server is performing. This is nice from if you're doing any sort of migration, whether it's from on-prem to cloud or physical to virtual or anything like that, or even to a new SAN, and you just want to know what the situation is. Couple of other terminologies. Sequential I/O is reads and writes, which are sequential on the spindle. And I want to talk a couple of things here about sequential I/O, because sequential I/O is a particularly interesting topic. Most common things we see in databases that are sequential I/O are transaction log writes. Transaction log writes write in one continuous stream. It's sequential. So, bulk loads will commonly be a sequential operation. The interesting thing about sequential ops and solid-state drives is by themselves, solid-state drives aren't really any faster for sequential operations. We're going to talk more about tiered storage later in the session. That said, if you use one of the fancy new all-shiny flash arrays from pick your vendor, Nimble, Pure, Tegile, EMC, they all have them. Those guys, what they all do is they have some firmware that when it sees your sequential I/O traffic coming in, it will spread that I/O and effectively make it random when it gets to the disk layer. So even though Windows, well, SQL Server is sending sequential I/O to Windows, and that's getting sent to the disk device, when it's actually written, it's random and all over the disk. And the reason why is solid-state drives are really, really fast at doing really random I/O because there's no controller to spin up or anything like that. There's kind of a map. They're not really that great at doing real legitimate sequential I/O. They're not going to be slower than a spinning disk, but they're not going to be much faster for you paying more. So there's not a whole lot of benefit to writing your transaction logs to something like just a normal solid-state drive, unless you know the firmware does something interesting like that. Next, random I/O. This is probably the biggest reads and writes of database I/O. Especially in an OLTP system where you're not doing a ton of big sequential operations. These are really expensive on spinning disk because if we think about how spinning disk works, if that head has to go back and forth and seek, like on a record player, that takes a lot of time. We have latency involved with each of those reads and writes, and it's important to know. And somehow we had a little bit of a duplication here, so. Here's our storage area network, and this is just kind of an image of what a SAN looks like. We have our server infrastructure that sits on top of some connectivity, whether that's fiber channel, iSCSI, or network attached storage even. It's effectively the same thing. And then we have a shared storage infrastructure. The big thing to know about SANs is they're fully redundant at all layers. All the network paths are redundant, power supplies are redundant. They tend to have large battery-backed operations. So all those things mean you have a fully redundant environment. That doesn't mean your SAN protects you from all failures. My favorite all-time DR story, I was on call. I was working for a major global pharmaceutical company, and I was on call Oracle DBA at the time, and I got paged that a database was down. And I logged in, it was a Unix server, and I expected to see a prompt with like my database name and the present working directory in it. And I didn't see anything. I just saw a number sign, or a pound. So I tried to list the file system to see what was going on, and I got no response. I'm like, this is weird. I don't think I can get this database back online. So I'm like, I'm gonna call my boss and say, hey, Alicia, what's going on with this server? I think we need to escalate this to the Unix team. And she's like, oh, Joey, I'm sorry, I forgot to call you. I didn't mean to say that. A major SAN vendor came in to decommission the SAN today, and they took the wrong one. So our entire labware environment for the company was down. Our fledgling, because this was about 2008, our fledgling VMware environment was gone. And yeah, this was kind of old school, so we had tape backups. So we had some DR, so we had the Oracle equivalent of database mirroring at the time on, but some of those failovers failed because of some complexity. It took us about a week before we fully recovered from everything. And that's not the first time I've heard of such things happening. So what is a SAN? Like we said, basically a specialized computer for storage. It consists of that computer, which the SAN vendors will frequently call a controller. Depending on your SAN vendor, your controller is probably either going to run Linux. Believe it or not, EMC used to run NT351, a special build, up until like 5 years ago. Because frankly, it's not doing that much. The only problem with that was that those NT351 was only 32-bit. So the cache could only ever be 3 gigs. So that was the reason why they made the major architecture change. It's going to have switches, so you can have, they have what we call back-end ports and front-end ports. And the back-end ports are going to go to your servers, and the front-end ports are going to go to the hard drives. SANs, by their nature, are not performance devices. There are some SANs, especially in the all-flash array category, that are really designed for optimal performance, and this has really changed, I'd say, in the last 5 years, now that you're seeing a lot more all-flash. But in the past, if you're on legacy infrastructure and you have something like a big EMC VMAX or some of the 3 XIV IBMs, those devices are more designed for capacity and optimization and not just sheer performance. Always, always just remember the ultimate performance in a system is gonna be direct attached storage, just because the latency is gonna be lower. Even though Fiber Channel has really low microsecond latency, if your storage is nearer to the server, then it's gonna go faster. SANs can be used for redundancy and DR purposes, so if you wanna build a failover cluster in SQL Server, you can use a SAN to provide that redundancy. Some SANs also do disk-based replication. This is a frequent fighting point between DBAs and their SAN admins, because a lot of times the SAN admin will want to use SAN replication for the entire DR solution, and sometimes, especially in a VMware environment, they'll use that in conjunction with Site Recovery Manager. You lose some control over your failover process, that can be problematic. The other thing to know about is that your SAN admin may come to you and say, hey, we want to do SAN snapshot-based backups of your SQL servers. Don't let them do that. SAN snapshots are wonderful for one thing. If you're doing an application upgrade that you're worried about going sideways, and you have downtime, you can stop your SQL server and take a snapshot of your server with SQL Server down. That's really cool, because you bring SQL Server back up, you apply the changes. If anything goes terribly wrong when you did the application changes, you can then just go back to that snapshot. Quick warning, because this is another horror story from the field. If you do that, the snapshot should take 30 seconds or less, because it's simply a snapshot of the disk. I was working with a customer. We were doing, because we didn't have enough hardware, we were doing an in-place SQL Server 2008 to 2014 upgrade on a failover cluster instance, which I didn't really feel comfortable doing. It was supported, and in-place upgrades aren't a terrible thing, but there was a lot to go wrong, and if I would have preferred to be on a newer version of SQL Server in order to do this. And sure enough, the install went sideways. I couldn't recover. And I hadn't really been paying attention because it was late, but the gentleman I was working with at the company said, hey, yeah, the colo took a SAN snapshot. It took like an hour to run. And I was like, I didn't think about it at the time, but I was like, that's really unusual. Well, it's 4 a.m. We can't get the cluster back up and running, so I'm like, let's revert to the snapshot. Turns out they had cloned our ones. So effectively, we had to do a full restore instead of just snapping back what we had. So we were down an extra 4 hours that we didn't need to be. But snapshots can be really good for that. And then finally, your SAN's gonna serve a whole lot of infrastructure. So there's a whole lot of servers and applications. It's a really critical piece of your infrastructure. One thing you always may wanna ask for applications that you have really highly available is if you have 2 servers in, say, an availability group or a mirroring situation or even log shipping, you'd want those 2 servers, even if they're in the same physical location or geographic location, to be on 2 different storage arrays. That way, if one storage array goes down, if the vendor comes in and takes the wrong array, you're still up on the other array. What you want to avoid is when you have your backups, your primary and your secondary copy all on one array, because if you lose that, you're really hosed. So these are kind of important questions to ask your SAN admin. You know, where is the storage you're giving me? Where are my backups going? All those sorts of things. So array cache. Let's step back a second and talk a little bit about array cache. So we think about our SAN. Our SAN's just a computer. So our SAN effectively has its own buffer pool that's known as the array cache. OLTP databases, for the most part, don't do a whole lot of reading. They're mostly writing and inserting data. If we think about a sales system where we're entering new sales, we're doing some lookups maybe to do updates, but for the most part, we're not doing a whole lot of reads. So an OLTP database won't take that much advantage of a read cache because it's not gonna, the pages that it's getting from disk are gonna be different almost every time. OLAP databases, online analytical processing databases or data warehouses, make good use of the SAN read cache. The reason is we're running this, all that data we're getting from the OLTP system, we're reading in from an OLAP database, or from a fact table. So we have our fact sales table, and we have 10 people running the same sales report every day. That data is probably gonna live in the buffer pool, but if it doesn't, it's gonna do pretty well in the SAN cache. Also, we're usually only updating those a few times a day, so we're not constantly updating. One frequent configuration for OLTP systems is to reduce read cache and increase write cache. OLTP database that have high buffer cache hit ratios, so if you have enough memory allocated to your SQL server that's running your OLTP system, you can frequently have the read cache disabled. And by the way, this all kind of goes out the window if you're using in-memory OLTP, or as we like to call it, hackathon, because that was a much cooler name. There is no one correct setup for this. Every system is gonna be different. The other thing too is you really can't tune your array cache based on one workload because your SAN is used by so many things. One warning I will give you, and I'm gonna drop in some cloud tidbits during the day, or during the session. There's a slide at the end, a couple slides at the end around Azure, but Azure lets you control this on an individual disk level. You can either enable a write cache, a read cache, a read-write cache, or nothing. You don't wanna use the read-write cache with SQL Server ever. There's a reason for this. For caches to be safe, they need to be battery back. Because let's think about the way memory works, typically. We'll talk about that later as well. But if we write something to memory, and it hasn't been flushed to disk, and the server gets powered down, what was written to memory was lost. Well, as far as SQL Server knows, when it wrote to that disk array, and the disk acknowledged the write, even though it was the cache, SQL Server thinks it wrote that data to disk. So as far as SQL Server is concerned, it's on disk. If all of a sudden that machine crashes, SQL Server is gonna come back and look for data that's on that page that it wrote, and it's not gonna be able to find it because it never got flushed out of memory onto disk. So always make sure your cache is battery backed. I'm not sure if anybody still does this I know not many people run physical servers anymore, but on physical servers, you'll frequently have a cache like that, and it's important to know if those are battery backed as well. Yeah, the question was, is that an array cache and RAID cache in SSD devices? Yeah, same basic concept. Even though SSDs are fast, memory's still faster, so they buffer the writes, so they're not constantly hitting the disk. No, typically it's on the controller. I don't know of anything that's on the HBA card that I know of, but there could be a configuration I'm not aware of where they do that. I know some vendors, multipathing driver, will have some degree of configuration. Like I know EMC PowerPath used to have some degree of caching configuration you could do. That was a paid device. The native Windows MPIO driver doesn't have anything like that I'm aware of. So what happens when a write cache on the array gets full? It won't flush to disk until a low watermark is hit, so it keeps a high and low watermark. And it will force flush once the high watermark is hit. Force flushing is gonna completely empty the write cache, so the write cache will be empty. This is effectively, logically, a checkpoint, right? So if any of you really have a good understanding of how the transaction log flushes happen in SQL Server, this is when the array is doing a checkpoint. And then force flushing is gonna disable the write cache until the write cache is disabled. What does that mean? It means all your writes are gonna go directly to disk, and they're gonna be significantly more expensive. From a database perspective, that shouldn't be a big deal, because your writes are gonna happen to memory. The only place you could really see a big performance impact on that is if you hit what we like to call a checkpoint storm, where you're just pounding SQL Server with insert activity, and you're getting constant checkpoints. Then you could see your disk latency go up. One of the kind of interesting things, as an aside to that, disk latency is kind of hard to measure in SQL Server. It's in sys.dm OS logical volumes, I believe. Don't ask me, I always use Glenn Berry's query. If you don't know Glenn Berry, he works for SQL Skills. He's got a great set of queries that are diagnostic and go against SQL's DMVs. And one of his queries will show you average write and average read latency per data file in SQL Server. That's good information. The problem with that information is unlike some of the other DMVs in SQL Server, there's no way to reset that information. So that data is from the time your instance has been running. So in a scenario like this, where you've had an instance running a while, and all of a sudden your latency shoots way up, you may not notice it in that view because it's an average since the instance was running. So it can be important to monitor this through things like perfmon. The counters I like to use there are disk seconds per read and disk seconds per write. I ran into this diagnostic scenario just last week with a customer where they were having a major I/O problem that we didn't see in the averages, and we were only able to troubleshoot using perfmon. Yes? Thank you, Erland.
Well, what I usually do when I want to get data from customers, I just sample like let's say every 10 minutes or whatever.
Mm-hmm.
But you can compute the average for each 10 minutes.
Yeah, that's not a bad approach. The nice thing about the perfmon is you can just see it over time, and you really only need 2 counters. So Erland's, the view is DM IO physical file stats, right? Virtual file stats, not physical. So if the write cache is adjustable, set it very low and set the high watermark very high, because you don't want to run into that situation where you're disabled, because that can lead to poor performance under very high write load. This is one of Denny's slides, because oh crap, the power went out. I have another good story about this. I was working at I worked for some really shady companies, I guess, before I started consulting. I was working for this $4 billion medical device company who really should have had better infrastructure, but we didn't. And in our second data center, we had a SAN, and we didn't have a generator at this building. And wait, there's more. The power went out every time the wind blew, like more than 20 miles an hour. But wait, there's more. I live closest to the data center. So every time this would happen, my boss would call me and he'd be like, can you go restart the SAN? Because all the servers can come up because they'll restart themselves. The SAN, you had to go push this special button on the bottom. I remember I had to lay on the floor. Most arrays have internal batteries. So this is to protect, like I was talking about, cache, because they want to be able to gracefully shut down the array, which is perform a checkpoint to flush that cache to disk. After the flush is successfully completed, the array is going to power down. Your data is where you thought it was going to be. I can tell you when this happens in not the good way. Your databases come back suspect. Sometimes they come up corrupt because they thought they had pages there. I know this was our development, where we kept all our development servers. So when the array went down on the weekend, it usually wasn't that big of a deal. But if the array went down during the week, or even on the weekend, our SharePoint databases would always come back suspect, and I'd have to recover them because SharePoint was constantly writing, even though nobody was using it. Once powered up, the flush cache is read and committed to the LUNs before it's made available. So this one piece kind of depends on the type of array you're using as to how it does the flush, but just know in general that this data is going to be flushed down a disk. You also want to make sure SQL is down before the array flushes. That can be a challenge, obviously. But yeah, there we go. So evolution of the storage arrays. This has come a long way. So way back in the day, we had spinning disk only arrays. Spinning disk, like we already talked about the limits. The way you get more I/O than 15,000 RPMs out of those is you span across disk, and you use RAID, which we're going to talk about here in a second. RAID provides two things. It provides increased performance by striping data across disk, so we're spreading our data out, and it also provides protection. All disk are going to fail. So they're mechanical devices, so they will all eventually fail. SSDs will fail for different reasons, because there's burn-in and gates and things like that. Microsoft has done some really interesting research, because it turns out running one of the world's biggest clouds lets you do some interesting research on hard disk failure rates. What they've found is that SSDs and spinning disks fail at about the same rate. So just be aware that everything's always gonna fail, and you need some sort of data protection, and we'll talk about some of the RAID levels after this. Hybrid arrays tend to have an SSD tier, a very fast spinning disk tier, and then a very dense spinning disk tier. Those very dense disks are very slow. We'll talk about how tiering works later, but generally speaking, the array is gonna manage where it stores data, but you'll also have the ability to pin data in those hybrid arrays. So typically, I would always pin TempDB to the solid state drive, and depending on the nature of my transaction logs, I might pin them to one of the spinning tiers for especially systems that aren't highly insert sensitive. And then if you have good budget, we have all SSD arrays. All SSD arrays simplify a lot of things. Unfortunately, when I lost PowerPoint, I lost 2 slides I added just before this. One of the things I wanted to talk about was the difference between object and block storage. So block storage is what you've probably been working with for the last 20 years. It's when a disk is just presented directly to the OS and you put your file system on it. Object-based storage is kind of this modern, cloudy, graphy thing where everything is a file. So if you've worked in Azure at all, you've worked on object-based storage. And you'll notice if you're ever working on an Azure VM and you add a disk to it, what you're actually adding is a VHD file, which is Hyper-V's virtual disk. Object-based storage is kind of interesting and hard to, changes the way we do RAID and all sorts of things like that. A lot of the new all SSD arrays are using this object-based storage model because it's more software-defined and less tied to specific hardware, and it allows them to do some better snapshotting technology and deal with growing amounts of data better. So RAID 0, and Denny described this with drinks. This is a straight stripe. It has no redundancy at all. If we spill any one of those drinks, no one can have drinks. RAID 0 is also exceptionally fast. One of the interesting things about RAID 0 is it's fast, and we have low cost and lots of capacity. So if each of those drinks were data, we'd have values 1 through 100, then values 100 through 200, 200 through 300, 400 through 500, et cetera. If we lose any one of those disks, we lose all of our data. A major vendor one time, who shall remain nameless because I've forgotten them, but I would name shame them if I remembered, did this VMware SQL Server benchmark on their storage and their hardware. So it was clearly, it wasn't HP, but it was somebody else who had storage and hardware. And they had SQL Server data files running in a 15-disk RAID 0 array, and then SQL Server's transaction log file in a 15-disk RAID 0 array as well. Somehow, they finished the benchmark without having a disk fail, and it was really fast, but it's something you would never implement in production. Because any disk failure is gonna lose data. That's not my misspelling, that's Denny's. And it can not survive any failure. I have a really, and it only requires 2 or more disks. I have a really good photographic description of RAID 0 on the next slide. Funny story though, and I said I was gonna drop some cloud things in here every now and then. If you're using Azure virtual machines, or if you're building a Hadoop cluster, one of the two, take your pick, you're gonna use RAID 0. And I know you're saying, Joey, you just told me RAID 0 is the worst thing ever, why would you ever do that? This ties back into that whole object-based storage model, and it's really kind of interesting. So in Azure, the Azure infrastructure always keeps 3 copies of your files in synchronous replica. So much like an availability group, where a write is not committed till it reaches the secondary, your disk, any write that gets written to your first disk isn't committed till it writes to all 3. So that's all handled by the backend infrastructure. When we present those disks to our SQL Server VM, we can use storage spaces, or sneak preview of my talk tomorrow, logical volume manager in Linux, to pull those disks together. And those solutions offer you a way to do RAID at the software level. There's no reason to do that because our disks are already protected with the 3 copies. And by doing that, we get the maximum capacity and the maximum performance out of those drives. So the exceptions to this, of course, are Azure. Hadoop is very similar to that model in that the servers themselves, because you always have a cluster of multiple servers, you use a lot of local storage. It's RAID 0, but your data has 3 copies. So RAID 1 is a full mirror of your data. There's no real performance benefit to having RAID 1. There's a high cost because, let's think about it, you have to have two of the same. So you're effectively having an active passive thing going on here, but you're only getting half the capacity. So if those 2 drinks represented 2 terabytes, we'd only have 1 terabyte of usable. It only requires 2 disks and can survive a single disk failure. So RAID 0 plus 1 is drives that are striped and then mirrored. So we're striping the data across 2 disks and then mirroring it. This also has a pretty high cost because we need 4 disks now. It does have very high performance, so this can be a good solution. Most of this RAID stuff is really still only applying with physical disk, spinning disk. SSDs use RAID, but you almost never think about it because they're so fast. This requires a minimum of 2 disks and can survive at least 1 spindle failure. And it also requires an even number of disks, like here that we have 4. And it may possibly survive multiple spindle failures. So if we lost the bottom set, we'd probably have a failure. If we lost 1 of each, we could keep going. RAID 10, or 1 plus 0, this is where we mirror the drives, then stripe them. Traditionally speaking, RAID 10 was the best performance model for a high throughput database before SSDs came around. This also has a high cost just because of the amount of capacity that we lose in this scenario. It is high performance. It also requires at least 2 disks, and it can survive 1 spindle failure and an even number of disks. 4 disks, yeah. RAID 5 used to be really awful. So this is one of those things that as we've evolved with more memory and more storage, there used to be a group of Oracle DBAs that had a website called BARF. It was the battle against any RAID 5 because the write performance on very old RAID 5 systems was really atrocious. That has changed as caches have gotten a lot bigger because we're almost never writing directly to disk. And this is one of those places where knowing about these RAID levels is interesting, but it doesn't really matter anymore because between having solid state, I mean, I think almost every array now has some level of solid state, if nothing else, to act as a buffer to the spinning disk. But RAID 5 is one of those things. It's low cost because you're striping. It requires 3 plus disk. It's a stripe with single parity, and that parity means there's a calculation to tell the disk where the data is and spread that data across. It can survive a single drive failure well. There is a write penalty, though, because the striping is written across. And generally speaking, it's good performance. I will give you a couple of caveats on this, though. If anybody has an EMC VMAX array, I know for a fact, because Denny and I figured this out a while back, that the SSD tier is configured to RAID 5. Unfortunately, that makes the SSD tier perform only slightly better than spinning disk. While that's cool that it performs better, you paid a lot of money for that SSD tier. You should get maximum benefit from it. So if you make it RAID 1 or RAID 10, it's gonna go 4 times faster, which is kind of bananas. That's the last time I've seen a major RAID 5 performance impact, mostly because we don't see that much RAID 5 anymore. It was more common in older machines. The other RAID 5 issue I've run into in my career is RAID 5 is CPU intensive for the controller. So if you lose a disk, there's a lot of CPU involved in rebuilding that array to make sure your data is captured. And we had, when I was working for the big cable company on the East Coast, Comcast, we had some really poor equipment that we had acquired for our VMware environment. I'm not gonna name the vendor, but they kept tossing drives and breaking drives in their RAID 5 configuration, and the controllers didn't have enough CPU power to rebuild those. So if we lost 2 drives in the entire array out of 100, the array was basically trash to us because we couldn't rebuild. So just be aware that these are kind of questions to ask either your storage team or have your storage team ask your vendor, what's our rebuild scenario if we have a RAID 5, if we lose disk in a RAID 5 environment. RAID 6 is Stripe with 2 parity, and this you'll see from certain vendors. I think NetApp uses a variance of RAID 5, or RAID 6 rather. And there are a couple of other vendors. These tend to be pretty vendor specific. This does have a higher cost per gig than RAID 5, and you'll note the 3 clear drinks and the 2 pink drinks. It requires at least 4+ disk, and it can survive 2 disk failures, so it's a pretty robust system. And you have the similar write penalty to RAID 5. NetApp, because of their architecture, tends to have a pretty poor write performance for database structures, and it doesn't relate to any of this RAID stuff. It's kind of like the way the operating system for the disk is written. I haven't worked on any of their later stuff, and I don't know how much the latest R&D. I know they bought an all-flash company last year, so I don't know what their environment looks like now. But I know in the past, I've had a lot of bad luck with it, and I know Monica's had a lot of bad luck with it as well. So disk alignment. This is an old problem that can still be an issue. Here's the worst part about this issue. You can fix it, but it involves moving all your data to another volume, fixing the alignment, and then moving your data back. So this is almost always a downtime issue. And usually, if you're on Windows 2003 and you have this problem, since it's 2017, I think, it's still 2017, right? I would tell you to migrate to a new server that's on a new OS that's like supported. It's much easier than fixing the problem. By default, Windows disks are offset incorrectly, which gives a 50% performance penalty. What does offset incorrectly mean? Correcting this can improve SQL disk performance by 100%. I'm trying to find where Denny has this. Anyway, the head on the spindle has an offset of where it thinks it needs to start reading effectively, and that's measured in kilobytes. And since it's wrong, every time SQL Server did a read, it would have to move the head that much further before it even could start the read operation. So 64 1K blocks or 64K IO, 100% of IO is impacted. This must be done before any data is put on the disk, hence me telling you it's really hard to fix once it's broken. And in order to do this, you need, in Windows 2000, diskpar. Is anybody running Windows 2000? Wow, I have 2 people running Windows 2000. Is the hardware, is the server like really yellow by now? You know, Compact's no longer in business, right? Windows 2003, diskpart. Windows 2008 Plus, it's automatic. I'm gonna use this moment to advocate for always using the latest version of Windows that you can for SQL Server. There are numerous reasons for doing this, not only being one of them. It's something I see a lot of ISV software vendors who will come up and say, we only support SQL Server 2014 running on Windows Server 2012 R2. Well, unfortunately for that ISV, the ISV for SQL Server is Microsoft. And they support running SQL Server 2014 on Windows Server 2016. So you can tell your vendor to go jump in the lake or find another vendor. I know it's easier said than done, and it's easier when I do it as a consultant because they'll listen to us. And here's kind of the way that looks. We have the default block layout here where we have a physical 64 block cluster, and we have that 32 block offset. 32 block, and since that's incorrect, where it's correct and we see that big gap on the end, and Denny did a really nice job of visualizing this, everything is nice and aligned in that corrected block layout. So if you're on Windows 2003, you still need to think about this. For the most part, it's not a big deal. So auto-tiering storage. This is one of my favorite storage topics, and I know when we introduced it at Comcast, my DBAs kind of freaked out a little bit. I talked about tiered arrays and hybrid arrays, and typically this is gonna be an array where you have some level of solid state, some level of really fast spinning disk, and some level of archive. This also ties into kind of modern storage architecture, and I know I talked a lot about why RAID kind of doesn't matter anymore for the most part, and the reason is the way the array manufacturers make this happen is they completely stripe all of your data across all of the disk in the array, as opposed to back in the day when a SAN admin would give you like four physical disks for your SQL data. Depending on your SAN vendor, this is gonna be somewhere between 768K of data and 1.5 megs in a stripe. The reason why they did this in the first place was it worked a lot better with virtualization. So it wasn't just for databases. Virtual machines, when you were limited to the actual disks, had really crappy I/O. This allows them to have pretty good I/O in a consistent fashion. And the way it works is we have our flash tier, our fast spinning disk tier, and then our archival tier. The array measures how frequently each block in the array is used, so it's storing a bunch of metadata, not unlike a database server. And when it sees that certain blocks are called more frequently, it's gonna move them up into that hot data tier in SSD. When it sees other tiers, other data that's not getting called, it's gonna gradually move it down to the cold tier, which is gonna be slower in spinning disk. And this gives the best overall storage performance. It's not, once again, this isn't gonna be a situation where you're getting maximal performance, but it's gonna give everybody the best overall performance. So it's a pretty good and solid solution. My DBAs were a little bit freaked out about it because they were concerned that data would suddenly move. We worked with EMC to kind of help them have some understanding of how it worked, and there's some math behind it, and pretty smart engineers who designed it. Your data is generally not gonna suddenly slow down, and database files that are active almost always live in one of two tiers. Here is the other problem, and the other thing that freaks DBAs about a little bit. There's no way of reporting on the array where your data is. So your data could have moved into the SSD tier, and you wouldn't know about it other than you might see improved I/O performance, but remember, it's not all of your data. So in the case of that EMC array, it's 768K extents is what they call it. One of the other vendors, I think 3PAR calls it chunklets or something like that. So it's completely, I wanna say transparent yet obtuse to the DBA. So you don't see anything, but the SAN doesn't see anything either. So you don't have to do anything to your data, and overall you should get pretty good performance. I will say this, some of the arrays allow you to pin things. And one of the things we did was pin all of our tempDB volumes. We created a special volume group on the array, and we created them in our SSD tier. At the time, I don't think this is the case anymore, but the EMC array I was working on didn't have any special, that randomization magic I was telling you about for sequential writes. So we put all of our transaction logs in the middle tier, which was our fast spinning disk tier, because that was where we were gonna get the best balance of cost and performance. Then everything else in terms of data files that weren't tempDB, we let this array manage it. We didn't have any, I don't want to say we didn't have any performance problems, but they were no worse or better than really before. So it worked pretty seamlessly and did its magic, and we didn't have to think about it. And just to kind of give you a little bit of a visualization on this, this is kind of what it would look like, where we have our tiers. We see our SSD tier at the top, our 15K fiber channel storage in the middle, and then our 10K SATA storage at the bottom. So I have data that currently exists in my SSD tier. And I have log that exists in my fiber channel tier. And this is kind of a gross simplification of this, because remember, our data file is going to be split into millions of extents. And it's going to drop down to that 10K tier if it hasn't been used. That drop, I couldn't do a two-phase animation here in PowerPoint. It's going to drop first to the 15K tier, then it's going to drop down to the 10K tier. And as will my log if we're not using the database. This is kind of the future. I say the future. This is the now in the storage. Almost any enterprise class array you're going to buy that has a blend of, that's not all solid state, is going to have this technology. Yeah, there's a question in the back. Mm-hmm. Interesting. Yeah. Did you have a specific question around it? Yeah. Do you know what storage array you were using? Vmax or VNX? Okay. The gentleman in the back made an observation that because of the different tiers, they saw really poor ETL load performance during this kind of situation. Typically, when I've seen that happen, it's due to a couple of things. The array cache not being big enough that all those writes are hitting disk consistently. Secondly, one of the most common specs I've seen of those arrays that the sales reps will try to sell is they'll try to sell it with a decent chunk of SSD, but a very small chunk of fast spinning disk, and then a large chunk of the very slow dense disk to try to get the cost per terabyte down. So that's kind of the danger, that is the one danger of those sorts of arrays. Storage reps are, well, they're sales reps. I guess that's all I need to say about that. And they, in general, they're measured by cost per terabyte, which, in my opinion, isn't the best way to measure it. Because especially when we were dealing with spinning disk arrays, so frequently, at least at Comcast, we would run all of our arrays out of IOPS capacity, so performance capacity, at like 70% of disk capacity. So we wouldn't actually fill up the whole thing because we were out of performance and we couldn't really use it anymore. So that's why cost per terabyte's a bad measure, but it's what the industry tends to use. So the question was, is there any specific combination I'd use for warehousing versus OLTP? I would probably, I mean, it would depend on the frequency of your loads. If, like, it's the classic once-a-day loading, I would try to increase the read cache on the array. I'm gonna get to this slide in a few slides, but I'll start to talk about it now. For warehousing, you should be using column store indexes now, and most of your loading is gonna take place in memory if you do that. And you're gonna offset a lot of performance. This is gonna be on the summary slide, but a sneak preview. The fastest I/O you've ever done is the one you didn't do. So if you can do more things in memory and have SQL act in a more optimal fashion, you'll get some benefits. No problem. This was a really great tweet. It's from a friend of ours who's a VMware V expert about thin provisioning. Thin provisioning was created so storage admins can lie to DBAs. If you're not familiar with thin provisioning, when you go to your storage admin and say, hey, I need 2 terabytes for this project, or I need 10 terabytes for this project next week, sure, I'll give you 10 terabytes, click. And your volume looks like it's 10 terabytes, but it's actually like 200 gig. This is a good thing. This is how you get more capacity out of the array, because for the most part, people don't use the storage that's allocated. But at the same time, the array can get over-provisioned. The array management software is designed to alert you about these sorts of scenarios. And as long as you have a good storage admin, you're never gonna get over capacity. Where I really worry about thin provisioning is two things. There's a performance impact, which I'll talk about in a second. The second is if your SAN admin is lousy, or if you have one SAN admin and he or she has way too many jobs and is way too busy and can't monitor this, you can get into a situation where you're almost over capacity. And SANs have lead time, right? It takes a while to get one, probably a couple weeks. And you can potentially run out of storage capacity and then you're hosed for a couple weeks. Other problem is performance. So when we thin provision things, that data is not written. So we know with SQL Server, when we grow a data file, that's expensive. When you grow a volume on a SAN, that's expensive. It's the same concept. It's got to zero out the volume. Thin provisioning is effectively doing instant file initialization, but on the SAN. So it's got to write out that file. And if you're doing double layer thin provisioning, where you're in a virtual machine, and you have a thinly provisioned virtual volume on top of a thinly provisioned SAN volume, you're gonna be writing a lot of zeros. Even more than you probably write to your SAN vendor, Budding. So just be aware of this. It's not a bad thing, but as a DBA, it's something I wanna know about. So it's a good thing to ask your SAN admin. Another brief political point with your SAN team to win them is always give back the storage you're not using. So I have another talk I like to do called picking the right fights with your server team for DBAs, right? So there are certain things you wanna fight with them about and argue your point. There are other things you don't. And that's really kind of a different discussion. But one of the things, when I was doing some research for that and doing some surveys amongst DBAs, one of the common complaints was that we can never get enough space for the volumes we need, data volumes we need, because the SAN admins are so tight with it. And because one of the reasons why they're probably measured on utilization and how much disk is actually getting utilized versus what's sitting idle. So measure your storage where you asked for 4 terabytes 2 months ago because the dev team told you this was gonna be a huge project and it turned out it was 20 gig. Tell them you can take back that 3.5 terabytes, I don't need it anymore. This goes a long way into currying favor when you do all of a sudden run out of backup space or run out of transaction log space late one Friday afternoon and production's about to go down and you really do need 3 terabytes. One of the things I was able to do at Comcast was kind of do metrics on all of our data and then assign specific volume sizes, and we landed on increments of 250 gig, because our average database or median database server was about 250 gig. The DBAs could request up to 750 without approval, and anything beyond 750 had to get approval because we wanted to make sure they needed the data. And we came to a happy medium there. So all flash arrays are very, very fast. There's a couple of interesting quirks that happen when you remove all I/O bottlenecks from a database server. First is you need a lot of bandwidth because that data is coming back fast. It's coming back way faster than spinning disks. So you need a lot of CPU bandwidth and just a lot of straight network bandwidth to the array. And if you're using local or all flash arrays, your servers may need more CPU. And this is counterintuitive, but when you return all that data fast, your CPU can process it faster. Normally, if you have slow storage, your CPU is just kind of hanging out going, hey, I need to process some data. So those things all apply. Other thing I wanted to mention here, and I'm going to talk a little bit more about SQL Server data compression in a few slides, but a lot of these arrays do array-based compression on your volumes. Some of them allow you to turn that on and off per volume. Some of them just compress the whole array. You're not going to get great numbers on your SQL Server compression because there's not a lot of data. But in some of the testing we've done with Pure and Tegile, and this doesn't apply, and it's a question you want to ask your storage vendor is, should I be using SQL Server data compression with your array? There's always the benefit that you'll be able to have more rows of data in memory in your buffer pool because you'll have more data on each page. However, you may see weird CPU behavior, like your CPU goes up significantly, or you may even see the compression not work as well on the array. So it's something you want to talk to your all-flash vendor about, because I'm a huge advocate of using database compression. So, but talk to the vendor about it and see what they think. I'm gonna throw a little caveat to that, and you should probably always use column store, because that's just a whole fundamental different architecture for a data warehouse. And even if the compression's not as good, all the other benefits of column store will outweigh any weirdness that you're gonna have with the SAN vendor and storage. There's two other types of memory that I wanted to talk about, or flash that I wanted to talk about, and these are relatively new. You may have heard of them in the last couple of years. NVMe, and this stands for non-volatile memory, and I forget what the E stands for, but these are very fast local drives. They're commonly used as a buffering layer in front of SSDs. So effectively, this is persistent memory, and one of the places I've seen this used in SQL Server a lot is for transaction logs and very, very high throughput systems. The other solution is NVDIMM, so DIMM like memory stick, non-volatile. So this is battery-backed memory, effectively, so you can write at the speed of memory. Starting with SQL Server 2016, and I talked to Kevin Farley on the product group today about this. I can't remember if it's at a certain patch level or if SQL 2016 just supports it out of the box. You can write the tail of your transaction log to that NVDIMM. So you can write the tail of the transaction log at the speed of memory, and it's gonna consistently get flushed down to the real transaction log. So if you have the tail of the log on NVDIMM and maybe the log on NVMe, you can get exceedingly high write throughput to your SQL servers. Really cool stuff. If you have the kind of workload that's really pushing the envelope of write performance, you're gonna wanna look at this stuff. It's surprisingly cheap. The NVMe stuff, you can get NVMe drives like 250 or 500 gig for a few $100. I mean, it's to the point that you can put it in your laptop now. I think the NVDIMM stuff is a little bit pricier, but it's still kind of interesting. So Azure in the cloud. Azure uses a specially designed object-based storage model. Like I mentioned earlier, from your VM, you're gonna wanna use storage spaces and windows to create a RAID 0 pool. And if you haven't seen how to do this, it's pretty straightforward. There are a bunch of tutorials online. One of the interesting things you can do with Azure now is you can now build failover cluster instances if you're using Windows Server 2016 and clustered storage spaces. So it will take all those local disks and make them into a clustered volume. Data protection is all handled by the Service Fabric, which is the engine that runs Azure. And always, always use premium storage for SQL Server and other databases. So if your manager or anybody else who's controlling your Azure budget tries to tell you, no, we want to save money on this dev system and run standard storage, run screaming and say no. I use standard storage with SQL Server for one thing: demos to show how bad SQL Server performs on standard storage. There's no performance guarantee on standard storage in Azure. Depending on your VM size, the guesstimate for performance is either 300 or 500 IOPS, which is extremely slow. You need to add a lot of disks to get to any respectable IOP number. Premium storage will guarantee you 5,000. So I lost a couple of slides. We're almost to the end when PowerPoint crashed, but I want to talk about a couple of things of what you can do to improve your I/O performance without having to call your storage admin. The first, and I mentioned it a couple of slides ago, is to use data compression. Almost always on modern systems, unless you have all flash, your bottleneck is going to be that storage layer. And by using data compression in SQL Server, you read fewer pages, and you store more data in memory. So you get better utilization of your cache, and you get faster reads. There is a little bit of a CPU penalty, because it's got to calculate that data, But overall, in most of my customers where I've implemented compression, you'll see huge performance benefits with it, especially if you're I/O bottlenecked. And most importantly, starting with SQL Server 2016 SP1, compression is available in standard edition. So yay, Microsoft, thank you for giving us that. The other things, of course, make sure your indexes are good and your statistics are up to date, because the fastest I/O you'll perform is the one that you don't do. So if you can optimize your indexing structure, that will all help. Always use backup compression, and unless you're on a server that's tapped out at 100% CPU all the time, which you should fix. Backup compression is also a huge benefit. It's also in standard edition since 2008 R2. That limits the amount of data you're writing to your backup appliance, once again, limiting the I/O. Yeah, question?
Question on backup compression.
Mm-hmm.
I don't understand that. Don't like that. Other stuff and
Good question. Denny and I think, have a series of blog posts, and I had to fight the SAN admin at Comcast about this. The question was, our SAN admins don't like us to do backup compression because they have this appliance that they paid way too much money for that does backup deduplication. I have a secret to winning this fight. Build a database that's legitimately a terabyte. So like if you blow up, if you have a database backup that's a database that's a terabyte, or you can blow up a sample database online, like one of the TPCH ones, back it up to the array with and without compression. You're gonna see, backup's not bad. You're only gonna see about a 20% performance hit when you go without compression, assuming your infrastructure is good and everything like that. Then restore it. Your restore from that terabyte's gonna be probably about the same as your backup compressed. When it's uncompressed, it's gonna take 4 to 5 times as long. Because what happens is that file gets deduped, and the array has to, they call it rehydrate it. So they have to effectively undedupe it, and then you're sending the full terabyte across the network as opposed to the compressed backup. Then what you do is get the business team you're supporting, and you go to them and say, hey, the storage team really wants me to do this, but if you ever have a failure, it's gonna take me 4 times as long to restore your database. And then the business team yells at the storage team's manager, and you win. Yeah, the other problem with that, and if you ever really want to make the storage team mad, do what I just told you to do, except do it across 8 databases and make them 3 terabytes each. The backup appliance doesn't have enough CPU to rehydrate all those at once, and it pretty much just melts down. Denny has a blog post on why data domains suck. And since EMC is not a sponsor, I can say that. In my opinion, if I were doing if I were making backup appliances, I would just run JBODs or disk arrays that are, man, I am not having any AV luck this week. But JBODs are just arrays that handle that, because there's no the dedupe thing's not worth it. Almost every database engine does some level of compression, and it works pretty well. So just a final couple of closing slides. Yeah, no problem. Explain what? Compression versus dedupe. Okay. Well, so here's the deal. If you have backup compression, it's in line by the storage engine. So you take that terabyte database, it's gonna back up down to somewhere between 400 and 600 gig, depending on the nature of your data. And you have to send and write 400 to 600 gig. If you back up uncompressed, you have to send and write that whole terabyte. So it's just a lot more data before you take into consideration anything else. When you take into consideration the CPU and the appliance, it's, yeah. The uncompressed. Because here's what's going to happen. The appliance isn't going to be able to dedupe your compressed backup. So it's going to get like a 1% reduction. So for it to blow that up is going to take no time at all. Whereas it's going to dedupe the heck out of your uncompressed backup, and it's going to have to blow that back up before it can restore. Not a fun process. Yeah, the rehydration is the problem. The question in the back? If they have inline compression in the array. So you're probably using DD boost with data domain. Oh, Pure. The inline compression with Pure is a little bit different. Do you need to back up your databases to your Pure? So that's always my first question, and I know they like, yeah, back up your databases, it's super fast. But I always, do you really need that sort of backup performance? And it's not because it's a bad thing. It's just because that stuff's expensive, and I'd rather not put my backups there if I don't have to. But that inline compression is different than deduplication. It's more like page compression. So you're not going to have to fully rehydrate that backup. It's just going to come across. You might see a little bit higher. No, you wouldn't see higher CPU in the restore. But yeah, that's fine. It's the deduplication that's really the bad thing. Mm-hmm. Yeah. Like I mentioned earlier, that's something you want to consult with your flash vendor about. I know for a fact, because I did some of the early testing with Pure. They've done a lot of testing with it. Some other vendors haven't. It depends on the nature of the compression algorithms they're using as to if you're going to get any benefit. Realistically, the only benefit you're getting to using compression, if your array has that inline-based compression, is that better utilization of memory. Because all the I/O stuff is handled by the array, so that's going on pretty well. But it's just better utilization of memory. Well, we're out of time, and I would love you to do session evals. Your feedback is important, and we appreciate it. So you can do that at passsummit.com. If anybody has any questions, I'll be up here for a few minutes after.